All right, this video is going to help you review for the Chapter 12 test. So you have the Chapter 12 review sheet, and what I'm going to do is I'm going to go over the answers to the review sheet and how to find those answers. So in example 1, they're given the box and whisker plot diagram as shown below. Which of the following represents the third quartile for this data set? Now you need to know what each value in the box and whisker step represents. So the first point is the minimum data value. The start of the box is the first quartile. The line down the somewhere in the box is the median. The end of the box is the third quartile, and the last data value is the maximum point in the data set. So if they're looking for the third quartile, they're looking for this point right here. Now, some of you are telling me that that's 19, but you have to remember to watch your scale. If this guy is 10 right here, and I only have 5 in between 10 and 20, that means each one of these tick marks is counting for 2 points. So it's not 19 that's the third quartile, it's 18. So number 1 is option 2. Number 2, which of the following residual plots indicates that a linear model is the most appropriate? In a residual plot for a linear model, I want my points to be random around the x-axis. So residual means random, and the scatter plot that's most random is option 2. In number 3, the ages of 15 employees of the Red Hook Curry House are given below. And those are the ages of the employees. We have to determine the median and the quartiles excuse me, for this data set, and also find the interquartile range and if there's any outliers. So what we can do is we can enter the data into L1 in our calculator, and then we're going to do stat calc 1 variable statistics, and that's our work in order to use the calculator to find the median and the quartiles, as well as the interquartile range. Okay, so what I've done is I've put my data in L1, and I'm going to go stat calc 1 variable statistics. My data's in L1, I don't have a frequency list, so I'm going to go down and calculate, and I want the median and the quartiles. So I'm going to scroll down, and my first quartile is 18, my median is 26, and my third quartile is 37. Now it also asks you to find the interquartile range, and the interquartile range is not given to us by the graphing calculator. We have to find that ourselves. The interquartile range is Q3 minus Q1, and you actually have to do that math. You have to do 37 minus 18 to get 19. Remember, outliers are when we have a data value that's very high above or below the rest of the data values, and that's 1.5 times the interquartile range, and you will find that there are no outliers in this data. If there were outliers, we could not put them on the box and whisker. So now to create the box and whisker plot, we have to create an appropriate scale and put each of the numbers in the 5-number summary on the box and whisker. So what I'm going to do is I'm going to start at 15, and I'm going to count by 2 to get my scale. And then I put a data point for the minimum data value, just like we saw in example 1. I'm going to put a data point for the minimum data value, which was 16. I'm going to put a data point for Q1, which is 18. A data point for the median, which is 26. Q3 is 27. And then the maximum data value is 44. I have a box that goes around my quartiles with a line going down through the median, and the whiskers out to the extreme values, the min and the max. Now, if there were an outlier, you would not put the outlier connected to the whisker. You would simply have the outlier on the number line as a data point, and then your whisker would go out to the second highest data value. Okay, number 4. Each person in a random sample of 10 ninth graders was asked, how many hours did you spend watching TV last night? And here's data for those 10 students. So one student said they spent 2 hours, another student said they spent an hour, another student didn't watch any TV. And part A says construct a dot plot. Now a dot plot, literally you just put dots on the number line, and we're doing a dot plot of the data of hours of TV. So all I want is a dot plot for the hours of TV. Doesn't have anything to do with the student number. So I'm going to put, since my hours of TV go anywhere from 0 to 4, I'm just going to spread out my number line a little bit so everything's not so crowded together. And I have a dot at 2 because the first student watched 2 hours. I have a dot at 1 because the second student watched for an hour. I have a point at 0 because the third student didn't watch any TV. I have a point at 3, a point at 4, a point at 1, a point at 2, a point at 2, a point at 4, and a point at 3. So we literally just plot points for each of those data values for the hours of TV. Now, part B, would you describe this data distribution as approximately symmetric or skewed? Symmetric means the same on both sides. Skewed means the data is high and then comes down low, or low and then comes up high. So those would be skewed. Now, since this data is, if I were to create or look at the top of that data, you can see I'm about the same on both sides. So we're going to say that this is symmetric because, again, it's about the same on both sides. If you wanted to describe a typical number of hours of TV watched for these 10 students, would you use the mean or the median and calculate the value that you measured? Now, there is a very specific answer. You cannot say the mean because it's the average. What you have to do is take a look at whether you have outliers or not. If you have outliers, the median is the best value. If you don't have outliers, the mean is the best value. In other words, if the data is symmetric, the mean is the best. If the data is not symmetric, then the median. Since this data is symmetric, we're going to use the mean because the data is symmetric. Now you have to calculate the mean. You can calculate that using your graphing calculator or you can calculate it by hand. But when you find the mean, you're going to find the mean to be 2.2. If you want to use the graphing calculator, you're just going to enter hours of TV into L1 and then stat calc 1 variable statistics. Okay, for number 5, the following table shows the bivariate relationship between height and arm span measured in centimeters for a group of men. And the first thing you need to do is create a scatter plot. So what you're going to do is you're going to look at arm span for the x-axis and height for the y-axis. And then you're going to create your scatter plot. So what I want you to do is I want you to pause the video. When you come back to the video, I'll have the scatter plot completed with appropriate scales. Okay, as you can see, I have breaks on both my x-axis and my y-axis. I have arm span labeled for the x-axis, height labeled for the y-axis, and I estimated my ordered pairs for arm span and height. So part B says draw in a line of best fit, and remember a line is going to be a straight line. You should be using your ruler to find the line that best fits those data points. Now part C is write the linear regression write the regression equation y equals ax plus b, which means you know that it's going to be stat calc linear regression when arm span is the independent variable. So what they mean is that the arm span has to be the x or the L1, and we're going to round all values to the nearest thousandth. So what I've done is I've entered the data into L1 and L2 already. I've got my arm span in L1, height in L2. I'm going to do stat calc linear regression. All the data is in L1 and L2. We're not going to worry about a frequency list or storing the equation. And we get y equals 1.105x minus 14.868. Remember, we're rounding all the values to the nearest thousandth. Now, part D says find the correlation coefficient rounded to the nearest thousandth. Remember, the correlation coefficient, this correlation coefficient is the R value. And right now, my R is not appearing on the graphing calculator. That's because I didn't turn my diagnostics on. So I'm going to hit the mode button, and I'm going to scroll down to where I see stat diagnostics, and I'm going to turn the diagnostics on. Now, when I run the regression equation again, I'm going to see my R value, and it wanted the R value rounded to the nearest thousandth, so that's going to be R equals 0.788. And then they want to know the kind of correlation. So if I was looking at this R value, how is the data correlated? Well, since this value is positive, it's a positive correlation, but it's not very close to 1, so we're going to say it's moderately or moderate and positive correlation. Remember, close to 0 means no correlation. Close to 1 or negative 1 means a strong correlation. Since 0.7 is kind of far away from 1, we're going to say it's moderate, so not as strong. Now, part E, using the equation from part C, So I'm going to use y equals 1.105x minus 14.868. It says find the height of a person, now that's your y value, with an arm span of 180 centimeters, and that's your x. So all I need to do is substitute 180 in for x. I'll give you a minute there to put it in your calculator. You're going to substitute 180 in for x so that you can get your y value, which is the height of a person. You're going to get 184.032. They want it rounded to the nearest centimeter, so you're going to have 184 centimeters. So not only do you have to be able to come up, you're going to have to be able to come up with the linear regression, you're going to have to use it as well. Okay, number 6, the 2006-2007 Arlington High School varsity boys basketball team had an excellent season, compiling a record of 5-5, which means 5 wins and 5 losses. The total points scored by the team for each of the 20 games are listed below in the order in which the games were played. And we have to complete a frequency table. Now, frequency table just means tell me how many values were between 40 and 49, how many values were between 50 and 59, and so on and so forth, and then we're going to construct a histogram. So at this point, you can pause the video, create your frequency table and your histogram, and when you come back to the video, I'll have both completed. Okay, so your frequencies for each interval of points scored should go 3 for 40 to 49, 7 for 50 to 59, 7 for 60 to 69, 2 for 70 to 79, none but in the 80s, and 1 in the 90s. Now what I want you to notice is I actually totaled up my frequencies to make sure I've got the total number of games when they tell me that there was 20 games. So I just added up my frequencies to make sure I got 20, so I know I wasn't missing anything. Now, when you construct your histogram, make sure you are labeling both the x-axis and the y-axis. The x-axis is going to be the points that you scored, and the y-axis is always going to be your frequency. I also want you to notice that I have a break because the intervals are not starting at 0. So if your intervals do not start at 0, you must have a break in there. Also, the bars must be touching, and the bars must be of equal width. So I have my bars that are 2 units wide. You can have yours if they're 3 units wide, but you have to be able to fit it on the graph, and you have to have the break in there. Okay, number 7. The table below shows the number of new stores in the coffee shop chain that opened during the years 1986 through 1994. It says using x equals 1 to represent the year 1986. That's important. And y to represent the number of new stores. So x equals 1 is going to represent 1986. We're going to write the regression equation that best models the data and round all the values to the nearest thousandth and explain your choice of regression equation. So what we can do is we can do a linear regression, a quadratic regression, or an exponential regression. Okay, so now it says use x equals 1 for 1986. When I go to my calculator, if 1986 is 1, that means 1987 is going to be 2, and 1988 would be 3, and 1989 would be 4, and each one of these is going up by a year, so each one of my x values is going to go up by 1. So my y value, my L1 is not going to be the years, it's going to be those x equals 1, 2, 3, 4, and 5. The y values are going to be the L2, which is the number of new stores. Now, in order to help me determine which equation I'm going to use, I'm going to look for what kind of change is happening in the y's. If it's a linear regression, I'm going to have about a constant rate of change, not exactly, but pretty close. If it's exponential, I'm going to have growth very quickly or decay very quickly. And then if it's quadratic, I'm going to have an up and down. So if you notice, if I'm going from the number of new stores, if I go from 14 to 27, that's about a 13 store increase right there. If I go from 27 to 48, that's about a 21 store increase. That's not too far off. If I go from 48 to 80, that's a 32 store increase. From 80 to 110, that's a 30 store increase. Over here is a 23 store increase. Over here, we're up to about 100 stores increased by. Over here, we're going up by about 200 stores, and over here, we're going up by about 200 stores. Since these are increasing quite significantly, a lot more than in the 20s and 30s, I'm going to use an exponential regression. I'm going to use an exponential regression because the y's are increasing quickly. So what you're going to do is you're going to put your data in L1 and L2, and then you're going to do an exponential regression.